Hi everyone, welcome back to Tech Education. This is part 3 series of durable functions. Before watching this video, I recommend you to watch previous videos and the link for the playlist is available in the description box. In this video, we will discuss what are the different patterns we have it in durable functions and the use case for each pattern. Before proceeding, let's understand what are Azure durable patterns. These are design approaches that facilitate the management of complex workflows and stateful operations. In simple terms, these are predefined solutions for common scenarios. Common scenarios could be consider that you have a workflow with multiple steps and you wanted to execute it in a sequential manner. For that, you have a pattern. Another scenario could be you wanted to execute workflow with multiple activities in parallel. For that, you have a pattern. So these patterns we'll discuss in the next slides. Now, what problems it solves? The first one is simplified management of complex workflows, meaning these patterns provide a structured way to handle workflows that involve multiple steps. It simplifies the process of designing and implementing complex systems. Next is reusability. As we already discussed, these are predefined solutions for common scenarios. We'll be reusing the design in a different projects, and the implementation will be consistent across different use cases. Next is maintenance. Consider that you have implemented a workflow with 4 steps. In the future, you got a new requirement where you have to add a new step or activity in the middle of these 4 steps. So you create a separate activity and then you mention the order of that particular activity in the orchestrator and then you will be done. Next is predefined design templates, and finally is its efficiency. So if you follow these patterns, we'll be implementing an efficient solution. Example, you have a human interaction workflow. So before you get the response from the user, the workflow will be in a past state. Once you get the response, the workflow will be resumed again. So it helps us in implementing these kind of complex workflows in an efficient way. The first pattern is function chaining. It is a pattern where multiple functions are executed in a specific sequence with the output of one function being passed as the input to the next. In this diagram, function 1 will execute it and the output of function 1 is an input to the function 2. Next, function 2 will be executed and the output of function 2 is the input for the function 3 and so on. Now let's understand this with a real-time use case. ETL, extraction, transformation, and load. Consider a use case where you are extracting the data from an external source, or it could be from the CSV file, etc. And you will be performing some validations or cleaning that data. And finally, you are saving the cleaned data into the database. If this is the use case, this is how you can implement it. First is client function. The client function will invoke this orchestrator function. This we are calling it as a data orchestrator. This data orchestrator invokes ingestion activity. Ingestion is like fetching the data from the CSV file. It ingests the data and passes that output to the orchestrator. The orchestrator function will pass the output of ingestion activity to the next activity, that is transform activity. So this is what I was saying it. So ingestion activity output is the input for the transform activity. This transform activity will perform transformation on this data. The transformation could be like removing the duplicate values, filling the null values with the default data, or it could be changing the date format, etc. After transforming the data, the output is sent to the orchestrator function. The orchestrator in turn sends the output of transform activity as an input to the load activity function. And the load activity could be saving data into the database, or it could be in some storage account, etc. So that is how the flow works. So these activities are executed in a sequential manner, and the output of one activity is an input to the next activity. That is what this numbers also indicates. Now client function is the first step. Next, orchestrator will be invoking the ingestion activity, second step, third step, and fourth. This is the sequential manner. Next pattern is fan out and fan in. This pattern allows for parallel execution of multiple functions and then aggregates the results once all the parallel tasks are completed. Executing parallel functions is called fan out. Aggregating the output of all the parallel tasks is called fan in. That is why we are calling it as a fan out and fan in pattern. In this image, function 1 will execute these three functions in parallel. The output of these three functions is sent to the function 3 where it will aggregate this data. Now let's understand little detail with the help of the use case. Consider a use case in a healthcare system where you are fetching data from a different sources. That information could be fetching medical history of a patient, fetching lab results of a patient, and then finally the medication records of the patient. Now the flow happens is the client function will invoke as usual orchestrator function. Orchestrator function will invoke all these three activities in parallel. That is why if you see the number, it is 1 and these all of them are 2 because it's executing parallelly. Once these activities completed, these activities will send the output to the orchestrator function. The orchestrator function will send the output of all these three functions to the another function called aggregate data activity. This particular activity function will aggregate this data and then save it into the database. We'll be able to fetch this data for the reports purpose. Third one is Async HTTP APIs. This pattern enables long-running operations to be triggered via an HTTP request where the status of the operation can be polled or monitored over a period of time. In this image, this start function will invoke do work activity function. This start function is an orchestrator function which will invoke do work. This is the work which is going to take more time. So once you invoke this, it will send HTTP status 202 and it will have a status query URL. And that status query URL, this get status function will keep polling it, and once it is completed, it will take the necessary actions. Now let's understand this with the use case. Payslip processing. Consider a use case where you are uploading multiple payslips using a web application, and the processing of these particular payslips will take around 4 to 5 hours. In that use case, in that particular scenario, you will be able to use this. The client function will invoke a payslip orchestrator. This payslip orchestrator will invoke process payslip activity. This is the activity function which is going to take 4-5 hours. So rather than waiting, it sends us the status URL. This status URL, it sends it to the orchestrator. From orchestrator, it comes back to the client function. The client function, instead of keep polling it, it sends this particular status URL to the another function called get status. This get status function will keep polling this particular status URL, maybe like for every half an hour or 1 hour. Once the status is completed, it is sending an email notification to the user. This get status function is not an activity function. This could be a timer trigger or any other stuff. Monitor pattern. This pattern is used to repeatedly check for certain conditions or changes over time, such as monitoring the status of an external system or resource. Wherever you have a polling requirement, you can implement monitor pattern there. In this diagram, this particular function is polling this particular function and checking the results of it. Now the use case for this is checking the resource health. Consider that in a production environment, you wanted to check the health of the resource. The resource could be SQL Azure, SQL Server, or any other stuff. Probably you wanted to keep polling it for every 5 minutes. And in case if there is any issue, if the service instance is down, or if there is any other issue, you wanted to redirect it to a different instance, or you wanted to send a notification to the admin department. In that particular scenario, you can use this. Since it has to keep polling, I have recommended timer trigger function. This could be triggering every 5 minutes, etc. And this invokes orchestrator function. Orchestrator function invokes resource health check availability activity. This activity function like opens a connection to the SQL Azure, and once it is open, it is successful. And once it is successful, it might be sending either true or false. In orchestrator function, you can have a logic. If it is true, it is fine. If it is false, you like to send a notification to the admin department. And the final pattern is human interaction pattern. This pattern enables workflows to wait for input or approval from a human before proceeding to the next step. If you have noticed it, in the previous patterns, there was no human intervention. Whereas in this pattern, there is a human intervention required. That is why this is called as a human interaction pattern. Consider that request approval is sending a notification email to the user. User will either approve or reject it. Based on that, the necessary actions to be taken. It has to be process approval or it has to be an escalation. And the best example for this particular pattern is leave approval system, where you apply for a leave and the manager either approves or reject, and the status of this particular leave is getting updated into the database. The client function is invoking the leave orchestrator function. This leave orchestrator function invokes send approval request activity. This send approval request activity, this is the activity function. Based on some business rules, it will send a notification email to the user. Till you get response from the user, this particular workflow should be in a pause state. It waits for the human interaction. That means your workflow will not be proceeded further. It will pause it there. Once you get the response from the user, it will resume the workflow. So it comes to the third step, that is the user. Consider that the user has approved it, and the user sends his approval data to the HTTP approval response. This is not an activity function. This is another Azure function which will be triggered by the user interaction. And this HTTP approval response will send the either approve or reject status to the orchestrator function. Till that time, this workflow is in the pause state. Once it gets that response, it will resume the workflow, and then it invokes this process approval response activity. This could be like saving data to the database and sending a email notification to the user, etc. That's it for this video. Did you found this video helpful? If yes, please consider liking it so that it can reach large set of audience. And finally, don't forget to share and subscribe. Thank you for watching.